Okay, in this video, what I'm going to do is show you how to run a chi-square test of independence in JUMP. So what I've done here is I've taken the example that was in the PDF notes within this week's learning module. Excuse me, if you remember, it was an example checking whether there was a relationship between gender and one's belief in the death penalty. So I have the chi-square template here. And, the question's complete, and, you could look at this in the notes, and I'm sure you read about this question already. One thing I left blank, actually, on the template was the p-value for the hypothesis test. We'll get that out of JUMP, actually. But the rest of the test is done, and we determined that there was not a significant relationship at the end of the test. So what I'd like to do is show you how we could get this information into JUMP, and because this is very number crunching intensive. In other words, calculating the expected frequency counts, like this expected frequency of 12 here in the contingency table. Remember, that was a formula which was row total multiplied by column total divided by n. So in that scenario it was 60 times 20, which is 1200, divided by the n, which was 100. And that's where that 12 came from. We had to sit there and calculate all those expecteds. And then naturally, the calculation of the chi-square testing statistic is very number crunching intensive as well, in order to get the chi-square testing statistic. JUMP will do all of this for you, and it will save you a lot of time and energy. Because let's be honest, the course isn't about number crunching here. That's why we're using the technology. All right, so what I've done is I've already created a data table for this and put it in. Now, just to give you a heads up on how you do this, remember you go File, New, and you select Data Table. Now, I'm not going to do that because I've already taken care of it. But let's give a look here on how the data table is laid out, because it is a little bit different than looking at the contingency table that you see. So for each of the categories in the contingency table, if I go back to the template, you can see that we have our male and female genders, right? And then we have 3 categories for each. We have favor, against, and undecided. So we have male favor, and that's the frequency there was 20. And remember that 20 in black there, that's the observed frequency. The little red frequency, remember, is the expected self frequency. And then we have male against, male undecided, and then the same for female. So in the data table in JUMP, notice that's exactly how I laid it out. So I created 3 columns. One's I called it gender, the other I called it belief, and then of course our frequency. So we have male favor, male against, male undecided with their respective observed frequencies, and then female favor, against, undecided. And you got to be real careful when you type this stuff in. Like everything's got to be formatted the same. For the variable names here for gender. Same thing for belief. You have to spell it exactly the same because, JUMP would not understand that and would see it as being different. All right, so now let's talk about how to run the chi-square test, because really running the test is pretty easy. Once you get the longest part of the test is really getting this information in the data table. All right, so what we do is we go Analyze, and you click Fit Y by X. Now, you've used this already. We've used the scenario for the bivariate data analysis when we were doing the linear regression and correlation and residuals. So we're going to set it up very similar. If you notice, by the way, gender and belief, they're categorical variables, right? And you can tell by the little red icon right here. And notice this little table right here, which shows you the type of analysis that JUMP will perform. It's really based on, what types of variables you're giving it. So where category, it's going to give us this contingency scenario right here, as you can see. All right, so we're gonna grab the gender and belief variables and drag them into X and Y, and it doesn't matter which one you drag them in. That would matter for linear regression and correlation, but for the chi-square test, it doesn't matter. And then, of course, we're going to grab the frequency column. Grab the frequency column and drag it into frequency. Okay, so I'm going to say OK and run the test. All right, so it creates a really nice output. It has what we call a mosaic plot. And what that does, as you can see, it checks each of the categories, like say gender versus against, and as you can see, that's a 50-50 split, and we knew that. When you go back to the table, you can see, it was 25-25, so you can see that was, from a percentage basis, that's a 50-50 split there. But then you start looking at, say, in favor, you can see that the wilt was towards the males. There was more males in favor than females, and it's showing that. And then again, for the undecided, there was more males undecided than females. And again, this is on a percentage basis. Okay, so there you have it. Now, the contingency table. And that's this big table right here. All right, well, JUMP's default output gives everything in terms of a percentage. Now, in our table, as you can see, we don't have that. We just have counts. So you could actually, change these outputs. So that the percentages are nice because it shows you the percent, for female against, female in favor, ... But we could change that output if I click right here, the contingency, and you can see count is selected, total percent, column percent, row percent. That's all default. What I do is I actually, oops, sorry about that. I like to actually change those and turn them off. I don't need all those percentages. The percentages are great, and you could use them and talk about it, but I like to select expected, because that'll calculate all my expecteds here. And I also like this other one called cell chi-square, and I'll show you that in a second where that is. So what I did was I left count naturally. Those are the observed counts, the expected counts. So observed frequencies, expected frequencies, and then this other thing called cell chi-square. Those are the only ones that I really care about when I crunch my test. All right, so now let's talk about what these things are, and we'll look at the table. So naturally, as you can see, and you can see it's in this order: count, expected, cell chi-square. So that's what this 25, 20, and 1.25. That is the observed frequencies, the expected frequencies, and this chi-square. What that really means is, how much did that category contribute to the chi-square testing statistic? Now, it gives the chi-square testing statistic, as you can see. It's down here. It says Pearson, 4.514, and then the p-value associated with that. And notice it's not in red because it's going to be a fail to reject scenario, which we already knew from the test. So in general, like what do we get here? Well, and you have to be careful here because I believe what it does is it puts everything in alphabetical order. So those female is first, male is second, against, favor, undecided. So the categories JUMP automatically puts them in alphabetical order, which is not the order that I have them on the template naturally. All right, so if you can see female against, which is, here. Female against is right here, right? That's that 5 and 8. Oh, sorry, no. That is the 25-20 right here. All right, female against. So as you can see, 25 was the observed frequency. 20 is the expected frequency. Now, what about this 1.25? What is that? Well, if I look at where the female against is in the calculation of the chi-square testing statistic, so where is that? It's here. That's this row. Really what it gives me obviously the observed frequency, the expected frequency. It bypasses observed minus expected and observed minus expected squared and jumps right to the part that contributes to this 4.51. That's what that means. It's really, many programs have this, and it's called the contribution to the chi-squares testing statistic. In other words, that one part of the category, in other words, female against, contributes 1.25 to this 4.51. Now, naturally, that's really nice because then you can see what's going on here. And you can see where, what cells contribute a lot to the chi-square testing statistic. And you could grab all that information out of there. Now, naturally, the 4.514 is here. That's the chi-square testing statistic, which is the sum of all those cell chi-squares that, the JUMP refers to, which for us is the sum of this last column of the calculation table here. All right, so what else do we need in here? Well, if I go back to the template, so naturally you could grab essentially all this information, all of this right out of jump. And again, this column here and this column here, jump doesn't calculate those, but really I don't really need those in the scheme of things. I just, I'm interested in seeing where these numbers come from.